Hello, algebra students. Mr. Lawrence here with a factor check video, and today we're talking about trinomials where a is not 1. Now, this one is a little more complicated, but it's not really hard. It's just going to take a little practice. Okay, I've got a trinomial. Oh, I see a GCF hiding in here. Better pull it out. I'm going to have a 2 times x squared plus 14x. Oh, not 14x, Mr. Lawrence. Silly. That would be 7x, wouldn't it? Plus 7x plus 10. Now I can factor the inside just like I did the day before when it was factoring trinomials for a is 1, because now a is 1, isn't it? So I need two factors of 10 that add to get 7x, or 7. Well, let me see, two factors of 10, I think 5 and 2 are going to work. So I'm going to have a 2 out front, and then I have an x plus 5, and an x plus 2, both in quantities, just like that. And bam, I'm done. Now, that one was a little bit trivial. It was actually a small mistake on my part, but it's good to point out the GCF. So let me give you another one here. Hold on one second. Let me do... Okay, let's try this one. This one won't have a GCF in it because I want to demonstrate the method for you. So this will be a new problem. It's going to be 21 x squared, 17x, and then plus 2. Okay, so now here's how we do this problem. Now, there's no GCF. I checked for it. It's not there. A is not 1, so it's not as simple as just going to two factors of 2. What I'm going to need to do is I'm going to list the factors of 21. So 1 and 21, 3 and 7, and that should be it. And then over here I'm going to list the factors of 2, 1 and 2. Now, my job is to multiply one of the factors of 21 to one of the factors of 2. For example, I might do 21 times 2. Now, if I do that, I'm forced to multiply 1 times 1. I want to add these together to get 17. So, look at this. What if I do 7 times 2? 7 times 2 is 14, yes? I'm forced to do 3 times 1. Well, that's 3. And 14 plus 3 is 17. So once you know you're going to do 3 times 1 and 7 times 2, here's how we break this up. Okay? We're going to set up two quantities. And we're going to put the 3 and the 7 as our lead terms. 3x plus 7x. Well, not plus, excuse me. Okay, it doesn't matter if the 7x goes here or the 3x goes here. Now, we're going to do a little loop and a big loop. And we're just going to follow our loops. The 7 got multiplied by the 2 to get 14. So we're going to go from the 7 little loop to the 2. We're going to go from the 3 to the 1. So we're going to go from the 3 to the 1. Now, the signs can be pretty confusing at times. One thing you want to know, if C is positive, B sign shows up in both quantities. Boom, boom. Now, you could also have said, well, 14 was positive and I was adding 3, so the 3 was positive, so I need that to be a positive 2 so I can get a positive 14. And I need that to be a positive 1 so I can get a positive 3. That's another way to do it. Okay. If you'd like on number 2, go ahead and pause the video and give it a shot. I'm going to explain it here in a minute. Okay, here comes my explanation. The first thing I'm going to do, there's no GCF, first thing I'm going to do is give myself some room to work, and I'm going to list the factors of 6. So I'm going to get 1 and 6, and 2 and 3. Then I'm going to list the factors of 20. 1 and 20, 2 and 10, and then 4 and 5 should be it. All right, I'm going to multiply one of the factors of 6 by one of the factors of 20. I'm going to multiply their partners together. I know I'm going to add because C is positive, and I have to get negative 23. Now, I'll tell you what, I'm just going to get positive 23, and then I'll show you how to adjust that. So let me see here. I need 23. So 10 and 12 isn't going to work. Let me see. See, I know I'm not going to do 6 times 20 because that's 120. That's way too big. 6 times 1, 20 times 1 is going to be 26. That's too big. 12 times 10, nope, that's only 22. It can't be 6 times either of those because those are too big. So it's not going to be 1 and 6. So let me see here. Oh, what about 3 times 5, which is 15, right? And 2 times 4, which is 8. 15 plus 8 is 23. So let me set up my two quantities. And we know that we're going to have a 2x and a 3x. Where did I get them from? Right here. How do I know the x is attached? Because I'm dealing with a 6. We need a 6x squared when we double distribute. Okay, so I have my little loop and my big loop. Well, the 2 got multiplied by the 4, so along, go from the 2, follow the big loop. I have to put a 4 there. All right, the 3 got multiplied by the 5. So I'll go from the 3 little loop, put a 5 there. Now, remember I told you before that if there's a plus back here, C is positive, this sign shows up twice. So I'm going to get a negative and a negative. Now watch, let's do this multiplication here. Let me change colors. Something I don't use very often. There we go. So if I multiply these two, I get negative 15x, right? If I multiply these two, I get negative 8x, negative 15x, negative 8x, negative 23x. There you go, it's factored. Okay, now it's slightly different, same procedure, but slightly different when C is negative. Still list the factors, 1 and 15, 3 and 5. The factors of 4 are 1 and 4, and 2 and 2. Still going to multiply one of the factors of 15 by one of the factors of 4, multiply their partners together, but then I'm going to subtract because 4 is negative. I'm not adding this time. So I'm going to subtract. So let me see. I got to subtract to get positive 7. So let me see here. It's probably not going to be 15 times 4. That's way too big. I'm guessing it's going to involve these numbers here, just from my number sense. And let's see here. I could get 10 minus 6. Nope, that's not going to be 7. That's not going to work. How about this? How about 3 times 4? That could be 12. And then 5 times 1 is 5. And I need to get positive 7 by subtraction, so isn't the problem going to be 12 minus 5? There you go, that's positive 7. All right, so I'm ready to factor. So I'm going to get my two quantities. Okay, I'm going to have a 3x and a 5x, like that. And then I'm going to do my two loops. I'm going to do a little loop and a big loop. All right, so the 3 got multiplied by a 4, so I'm going to follow the loop from the 3 over here and get a 4 there. And then the 5 got multiplied by a 1, so I'm going to go from the 5 here and put a 1. Now, which is going to have the larger product? The little loop or the big loop? Well, the big loop, right? So the big loop has to get this sign. It has to be the positive one. Because if it was the negative one, I wouldn't get a positive 7x. I'd get a negative. So then by default, I'm going to have a negative there. And there you go. You can check this by double distributing. So with my big loop, I chose to make it positive because it has a bigger product. 3 times 4 is 12. The little loop only yielded 1 times 5. Okay? So to do subtract them, the bigger one has to be positive because the middle term, the b term, was positive. Okay, if you'd like to try number 4 on your own, I think that's a great idea. If you haven't tried it, you might want to. I'm going to go ahead and list my factors and get going. So if you want to pause it, you go ahead. So let's see, 1 and 15, 3 and 5. 8 will be 1 and 8, and then 2 and 4. Okay, so I'm going to multiply one of the factors of 15 by one of the factors of 8. I'm going to subtract the products to get negative 54. Negative 54. I'm not seeing it right off the top of my head here. I'm wondering if I missed a factor or something. Let's see, I can get a 58. I wonder if I have a mistake in this problem, because I'm having a hard time seeing it. Let's see, I am getting tired. It is getting kind of late. 1 and 15, 3 and 5, 1 and 8, 2 and 4. Okay, I've got my factors right. I have to subtract. Can't be 8 times 15. That's too big. Can't be 15 minus 8. That's not right. 60 minus 2. No, 2 minus 60 won't work. 30 and 4 won't work. 40 and... yeah, I don't think it's going to work. Tell you what, let's go check the discriminant. So we're going to go A, B, C. Easy as 15, negative 54, negative 8. And so I'm going to need to go negative 54 squared minus 4AC. Okay, and it's okay to go to your calculator on this. Save you a little time, so let me see here. Let me get my calculator up and running. So we're going to get quantity of negative 54 squared when I get a second. All right, so we're going to go negative 54. We're going to square that minus 4 times 15 times negative 8. Let's see if we get a perfect square. Ooh, I don't know if that's a perfect square, so I'll take the square root. And you can do that by raising it to the 1/2 power. And sure enough, it's not a perfect square, so this one is prime. I hadn't intended to give you a prime one. I must have made a silly mistake over here. Let me check my math again really quick. And let's see here. Oh, Jiminy Christmas, I see the mistake. All right, you can't see it, but I can. So let's retry this problem. Okay, this is a good learning experience though, and when you run into something that's hard to do, you check the discriminant, making sure that it's factorable. This one was not. Okay, so, all right, here's the mistake. That's not supposed to be a negative 54. I don't know where I got that from. It's supposed to be a negative 14. Okay, it's supposed to be a negative 14. Yeah, that's right. Okay, so again, I'm going to list the factors of 15. 1 and 15, 3 and 5, okay, 1 and 8, and 2 and 4. Now I need to multiply one of the factors of 15 by one of the factors of 8, multiply their partners together, subtract. How do I know to subtract? Because C is negative, to get negative 14. Ooh, I think I see it right off the bat. How about 5 times 4, that's 20, and then 3 times 2 is 6. And if I did a negative 20 and a positive 6, I'd get negative 14, wouldn't I? All right, so get my two quantities going here. So I'm going to have a 3x and a 5x. And then I'm going to do my little loop and my big loop. All right, little sound effects there for you. I'm getting tired trying to keep myself awake. Okay, the 5 got multiplied by the 4. So follow the 5 to the 4. Hey, wait a minute. When they got multiplied, the 20 was negative. Do you think that means the 4 needs to be negative? I think it does. The 3 got multiplied by the 2. So I'll follow the loop from the 3 over here to the 2. And I got a positive 6, so I bet that means it needs to be a positive 2. Now, I explained it differently in that problem because I like to give you multiple ways to think about it. You can pick the one that works best for you. But if you check it out here, we said on the last problem that the larger of the two products gets the sign from B. Well, 3 times 2 is 6. 4 times 5 is 20. B is 20 is the larger of the two products. B is negative, so the 4 gets to be negative. The other one has to be positive by default because when C is negative, you're going to get one of each sign. All right, there you go. That's your quick check video. A little longer than the others, but this material was a little more challenging. Have a good night, everybody.